Hello everyone, my name is Dr. Sara Moghtadernejad and I'm an assistant professor in the Department of Chemical Engineering at Cal State Long Beach. I joined Cal State Long Beach in 2018 and since then I have been working on different applications of multiphase flow interactions and powder technology. My PhD is in mechanical engineering and I have postdoctoral research in powder technology and multiphase flow for different companies, pharmaceutical industry and aerospace. So when I joined the Cal State Long Beach, I have brought up the research experience that I gathered throughout my PhD and postdoctoral research to build this lab, which we name it Multiphase Flow and Surface Engineering. What we do in this lab is studying the interactions of different phases of solid, liquid, and gases, and see how these different phases interact with each other. So the application of my work is all the way from aerospace industry to biomedical engineering, and today I'm going to show you some of the stuff that we built in-house with my great students at Cal State Long Beach, and we will see how these projects have been supported by different industries and federal agencies. I'm going to talk about some of the research projects that we do here at Cal State Long Beach with my great students. So the first project is a work that has been funded from the grant that I received from Air Force Research Laboratory, or AFRL. And in this work, my student and I are trying to understand what would be the interactions of liquid with different types of solid surfaces for the purpose of reducing the amount of ice that gets accreted on the surface of the aircraft. And for that matter, what we will be doing is to 3D print different types of surfaces with different types of 3D printers that we have in the lab. And then once we created the surface, we have made some in-house devices that you can see here. With these devices, what we will be doing is injecting water onto the surfaces that were manufactured by the 3D printers and study the liquid interactions with these type of surfaces with the shadowgraphy method with the help of my high-speed camera in the lab. And as you can see, the students are working on these setups and analyzing the data that they gather through a high-speed image. So in here, the students are basically designing the experiment to get the image of liquid that is interacting with the surface that we made with the 3D printer. The process is to basically build the experimental setup with the help of SolidWorks, then making the basically droplet to fall from different heights to the surface that was manufactured with the 3D printer. Another project of mine that has been awarded a DoD grant is to work on type of surfaces that are being manufactured from metal powder. So I have a big 3D printer, not in this room for the sake of size, that this 3D printer uses metal powders to create different types of surfaces. Then these surfaces are going to be studied for the amount of corrosion that happens on them. So to study basically the quality of the printer and relate the properties of these powders to the quality of the part that is being manufactured by the printer and then its ability to reduce the amount of corrosion, what we need to do is to study the full characteristics of the powders, the metal powders. And now my lab is one of the few labs in the state of California that is capable of fully characterizing powders, and that is thanks to the devices that I acquired for powder rheology. So one of these devices is this FD4 or powder rheometer that I purchased. That we as CSULB are the only university in California that owns this rheometer that is capable of measuring all properties of powder from flow properties all the way to friction and basically amount of compression and tension that the powder can have. And then another device that you see here my student is working on is a particle size analyzer that measures with the help of laser, it measures the particle size distribution of powders. And another device that I have over there is measuring the density of powder. So together with these three devices, what my lab is capable of measuring all powder properties. Once the powder properties are measured, we are going to use those powders in the 3D printer that was acquired from my DoD grant. And then once the surface is being manufactured through that 3D printer, we are going to go back to the first step of characterizing liquid interactions with those type of surfaces.
Howdy, my name's Jack Thomas Hansen. I've been working in this lab since 2018. I'm a master's student in the Chemical Engineering Department. I have 2 published papers from my research within this lab studying multiphase interactions, and 1 on the way. I am a fellowship student, and I was lucky enough to get the summer scholarship. This lab has opened a lot of doors for me and given me a lot of opportunities, and I'm grateful to be here.
So hi, my name is Kevin. I started here at Long Beach with the chemical engineering program. I met Dr. Sara in one of my classes for kinetic reactions, and then also again for design. I liked it so much. I thought she was a really good professor, and I wanted to see what kind of research she offered. I talked to her, got a really good meeting, and I wanted to join. It worked out, so now I'm here. I've just recently started. I've only been here for about 2 months. I'm finishing up my bachelor's, and I'm also doing my master's here next semester. But in these 2 months, I've learned how to use most of these machines. I already started my paper, and hopefully it'll be out by the end of the summer.
Remember I said we have lots of stuff to characterize powders. So these are some of the other equipments that I purchased for the lab for the purpose of powder characterization. On the device that Kevin is working right now, you see that it is an acoustic mixer. So we get different recipes of powders to be able to mix them together in this mixer. And then once the powder is completely mixed and become like a cohesive mixture, then we put it in the printer and we start printing the parts that we want. But the tricky part is that the raw material, which is the powder, first needs to be characterized with the devices that I showed you before. Then we mix them together based on the recipe. Once we reach to a basically mixture that is completely uniform with the help of this device, then this mixture will be taken to the printer and used in a 3D printer. After our powder is being mixed in this device, we are going to take it to another unique device that I purchased for our lab, and that is called the Gamlen tablet press. So this small piece of equipment is capable of doing many things. One of those things is to get the mixture of powder, compress it into small tablets, and then measure the amount of force that needs for the tablets to be made, and also vice versa, measuring the amount of force that needs for the tablets to be breaking into different parts. And now why is this handy for our lab? It's because before we make the device in the 3D printer, we want to know how much force is needed for that device to be compacted and how much force is needed for that to be taken into separate parts. So this is also helping us to measure the properties of the powders, but at this time when it has been compressed together. So another unique device that was manufactured completely in my lab is this unique setup that we made it from scratch with the help of my graduate students in the lab. And this device is capable of measuring the amount of corrosion that happens on different solid surfaces that are going to be manufactured through the 3D printing. So this is similar to a setup that AFRL, or Air Force Research Laboratory, owns. The only difference is that if I wanted to test my samples for corrosion in their lab, I had to pay around 5,000 K for each sample. So rather than paying that money, I decided to make it in-house ourselves with the students, and this is how this device works. So Zach, could you please turn on the device? So it has like blades that you see. We put the sample on these blades, and the blade starts to rotate. Water will come out through these needles on the surface, imitating rain, and then you can imagine that your sample is rotating like a wind turbine. Rain is coming to it, and then we leave it for as many hours as we want just to simulate rain. And then after the rain is finished, we take out the sample, we start to characterize it with the devices that I have in the lab. So we can now turn it off. So with that being said, basically I want to introduce you one of my first students who joined to the lab, Mr. Zach, and he's going to talk about his projects and achievements so far.
Hi, my name is Zachary Johnson. I'm the lab safety officer here in the Multiphase Flow and Surface Engineering Lab. I started with Dr. Sara a very long time ago. It was actually before we had this room, so we were doing research in Sara's office, researching papers, kind of planning the next opportunities for when we got the space. I started as an undergrad. I'm a biomedical engineering undergrad. I had no plans of doing my master's. After working with Sara and kind of seeing how lovely research is, I decided to do my master's in chemical engineering. It's been quite the ride, but I wouldn't change it for the world.
So here was a little bit of an overview of the capabilities of my lab, Multiphase Flow Research Lab, located at VEC 127. If you are interested in doing pure research that has different applications, please feel free to contact me, and I would be happy to have an interview with you, see what your potentials might be, what your interests might be, and then you would be more than welcome to join my lab. But remember, you have to be motivated to do research, and then my lab would be your place. Thank you very much, everyone.